We're coming to our next part of this applying equations lesson. Once again, there are the guidelines: read, plan, solve, and check. And we're going to be looking at mixture problems. These first types of mixture problems are involving values or money. This is similar to a rate times a time equals a distance. In this case, your rate is how much you're paying for a certain thing. So it's like dollars per piece or something like that. There's also going to be a totals. So it says 2 types of soft drinks are mixed together to make a fruit punch. Orange drink sells for 89 cents for a 2-liter bottle, and lemon lime drink sells for $1.19 for a 2-liter bottle. How many 2-liter bottles of each must be mixed to produce 30 liters of fruit punch that sells for $1.09 for a 2-liter bottle? So we're mixing a couple different things together to make a fruit punch. What are some important words or key phrases or a type of problem? Well, it is a mixture problem because we're mixing 2 different types of drinks together, and they're different values, 89 cents and $1.19, and then your combination should be $1.09 for 2 liters. The question here says how many 2-liter bottles of each. So those are our unknowns. The amount of orange drink and the amount of lemon lime are our unknowns. So that's what we want to find. So how many 2-liter bottles of each must be mixed to produce 30 bottles of all together. There's not really one that's related to the other specifically, so we can choose either to be our main variable up here as we choose it for our main unknown. There's not one that's being compared to specifically, so we can choose either. So let's just let orange, let x equal the liters, or let's be careful with this, number of 2-liter bottles of orange. All right, so that is our variable for the orange. What is our variable going to be for, or what are we going to do for the lemon lime? So we have the number of 2 liters. And this is tricky, so think through it. Well, we want a total of 30 liters. We want a total of 30 liters, so we can take our total and subtract what we're making, or what the number of 2-liter bottles of orange. But we have to be careful because it's 30 liters of fruit punch. Well, if we're looking for 30 liters, but we're talking about 2-liter bottles, so how many 2-liter bottles would this be? So this is the tricky part. This is just actually 15 2-liter bottles. And so realizing that, we're going to, since we're talking about number of bottles, we're going to take 15, which is going to be our total, minus x. Because if we have 15 bottles, 15 2-liter bottles of the fruit punch, if x of it is orange, the rest of it, so 15 minus the x, will give us how many lemon lime bottles we need. So had to be careful about that. So now that we've got that straightened out, we're going to come down here and make a table. We're mixing our orange along with the lemon lime to make a fruit punch. And we want to think through these. So we're going to make a table. And in this table, we're going to have our number of bottles. We're going to have the cost per bottle. So let's think through that. So how many bottles of orange? Well, up here we said that's going to be X. The cost per bottle is 89 cents, so we'll put 0.89. And this is over here the total spent, or total, so our total is column. So this is the total amount of money we would spend on orange. So if we have X bottles and they're 89 cents a bottle, that's going to be 0.89X. Down here, our lemon lime, we have the 15 minus X. Squeeze that in there. These are $1.19 per bottle. Oops. Put in an extra number there. $1.19 per bottle. And so this is going to be 119 times 15 minus X. Our punch, the actual fruit punch, we know this is going to be 15 bottles because we knew that up here. This is supposed to be $1.09 for the mix, the fruit punch. And so what's our total over here going to be? Well, that's going to be 15 times 109. So we have 15 times 1.09 gives us 16.35. So that's going to be the total cost. And now that we have this is going to be similar to when we dealt with interest problems, because we have the money spent on the orange drink plus the money spent on the lemon lime drink will give us the total money spent. So we can do 0.89 plus the 119 times 15 minus X is going to equal the 1635. And as we work through here, we have the 119, we're going to have to distribute 119 times 15, 17.85, so we have 0.89x plus 17.85, distribute the 119 minus 119x equals 16.35. We can do a few things here. We can add these together. So 89 and negative 19, or negative 1.19 is going to give us negative 30, negative 0.30, sorry. Or you could just put negative 0.3. And at the same time, so I added those like terms. I'm going to go ahead and subtract 17.85 from both sides. And so 16.35 minus the 17.85 gives us negative 1.5. Go ahead and divide both sides by the 0.3, negative 0.3. Have it as 0. You don't really need the 0. And we get, well, I'll put it right in there. We get x is equal to 5. Well, x is equal to 5. Well, what did x stand for? That was the number of 2 little bottles of orange. So 5 orange. Well, if we needed 15 altogether, 5 are orange, 10 have to be the lemon lime. And so there is solving a mixture problem. And that was a mixture problem using some money involved there.